Good. I think we can start. So thanks everybody for joining. This will be a learning sessions where basically I will walk you through the different steps we made to create our NFT smart contract, and we'll show you also some learning resources which I used to basically learn this. Like more or less 2.5 weeks ago, I had no idea about programming Solidity, so I'm not an expert yet, but I think at least for now, our smart contract is is doing quite a good job. Money is still there, so seems we don't have like a huge bug, and nobody drained it. Um, and yeah, so basically, I'll share my learning experience with Solidity, and I hope this will help you like pick up Solidity programming yourself. I also found that I didn't find any like really good tutorial online that takes you through all the steps to create an NFT contract. So this is my attempt to do something like this, and yeah, but I also share a couple of other tutorials that were very useful. And then this is supposed to be an interactive session, so just speak up whenever you have a question or something's not clear, and I'll try to explain it, right? And maybe before we start, I just wanted to see, does anybody of you have experience with Solidity or writing smart contracts? Or are you here basically to just to learn? All right, so nobody speaks up, so I assume you are beginners for smart contracts. All right, so let's jump in. First, I want to start with our repository on GitHub, which contains basically the whole project. So it's public. It's not perfectly documented, but it's more or less okay. Still working on it a little bit to improve the documentation, but it should be enough for you to get things started. And yeah, so this will be our starting point. So feel free to check it out after that, play around, and you'll be able even to like deploy your own version of the smart contract if you want. Yeah. So before we start, what is a smart contract? So I wanted to show you this. I don't know how many people really know this in detail. So what I'll show here is this is actually our production smart contract, which we really use for the NFTs for the community, and this is this is now running live and deployed on Polygon. So the website I'm using is called Polyscan. Maybe some of you are familiar with Etherscan, which is like the same thing for the Ethereum blockchain. Polyscan basically allows you to inspect every wallet address, every transaction that happened on the blockchain, and this one is for the Polygon blockchain. And so every wallet address is either like a personal wallet or somebody, or it's a smart contract. And the cool thing about smart contracts is that all the actions of the contract are defined by code, and we can usually inspect this code and interact with it. And actually, you see that Polyscan allows you to interact with the smart contract as well. And what you see here are basically all the transactions of the contract. These are usually people that were minting the NFT. Here we have somebody that transferred it from one wallet to another. And in the beginning, you see all transactions. You see also the first ever transaction that created the contract. Oh, I forgot to share it. All right. Now wait. Okay, so I was talking, assuming you see it. All right, you see it now? Okay, so, okay, again, here's the repository in GitHub where you have all the code and some documentation. And this is what I was showing is like the Polyscan smart contract. So this is our smart contract we use for the NFT. And as I was saying, here are the different transactions that happened in this smart contract, like minting, transferring, and the first transaction that actually created the contract is here. And you can even click on any transaction and you see, so this is 12 minutes ago, somebody minted a token, you see it's successful, you see who initiated it, and you see that it minted one of the underfitted tokens, just the ID 131. And you see also the amount of money they paid and the transaction fee. Right. So this you can do basically with any wallet out there. You can put here your own address and see your transactions. But what you're interested now is looking into the contract itself. So you can go here to contract, and the standard practice is that you see here all the code of the smart contract. Some people don't do it, but this is the usual practice. So you can actually see the whole code, and here you can interact with it. So important thing is the smart contracts, they have two kind of functions, read functions and write functions. Read functions you can always do, they don't cost any gas fee, but they cannot change the state on the blockchain. So what you see here are some constants like the maximum supply, some price factor we use to increase the price, and here are some functions that you can call. For example, I can check, for example, who is the owner of token ID 5, and this is, for example, Santiago's wallet. This one is mine. So basically, this is easy. You can always just call the function from here, and then you have the write functions where you need to collect your wallet to execute them, and they always charge. Then you need to pay the transaction fee for the blockchain. So, for example, we have a mint function where you can mint a new token, you can transfer a token, and so on. So this is like the basics of where you see the smart contract. And you can use this, for example, to also inspect smart contracts of other projects. And it's actually a good source for learning. You can pick one of the projects you're confident in, and then you can check out the smart contract. All right, so let's see how we can write ours. So I have a couple of tutorials. I'll share the links with you after that. That basically walk you through the steps, how to create a contract. So this is one on ethereum.org. It's special for NFT contracts, but it's for kind of contract that is simpler than ours, so it won't cover all the use cases, but it's a good read. Another one is by Hardhat. Hardhat is a library for writing and deploying smart contracts that we're actually going to use in our project. They have quite a good tutorial as well, but they give an example not with an NFT project, but with a coin, with a token, which is a bit different. And then I really like this one because it's more focused on the whole process, how to set up your environment, how to more or less how you go about writing the contract, testing it, deploying it, managing configurations, and so on. So this is by Oliver Jumpets, and this is actually one of my favorites. All right, so now we are ready to start with our smart contract. And one thing you always need to consider is that once we deploy a smart contract on the blockchain, it's immutable. You cannot change it anymore. It will stay there forever. You cannot delete it, you cannot change the code. If you mess something up, you actually need to deploy a new one and connect it to your database, which is a hassle. And you can imagine now that a lot of people have minted the tokens. This is very difficult to do. So it's a good idea for your smart contract to be very well tested, and it's also a good idea to not implement everything yourself, but for parts that are like common in contracts, to use some kind of template. And that's why where we started is the so-called Open Zeppelin contracts. So Open Zeppelin is like a library that provides different snippets of contracts that you can basically plug into yours, and it will basically implement many of the functions for you. For example, we now want to do an NFT contract, a non-fungible token. This means that we need to comply with the ERC 721 standard. So ERC 721 basically defines some common functions that NFT projects need to implement so they can interact with exchanges, for example, with wallets. You can imagine this like kind of a standard interface, and then every NFT project needs to implement certain functions of it. And they're like functions, for example, that you need to check who is the owner of an NFT, how much NFTs a certain account has. It needs to implement functions for transfer, for approving transfers, and so on. And basically this is all implemented by Open Zeppelin, so it makes it really easy for you to start, and at the same time gives you like confidence that these things will work, that you don't have a bug, because their snippets are very, very well tested, right? So they have here the so-called wizard, where you basically provide some basic information. Let's say we want to name it Underfitted NFT. We give it some symbol. The base URI will come to this in a minute. And then you can click some different functions that features that you want your contract to have. For example, I can click mintable. This means I want to have a function that allow me to mint a new token. And you see what happens is that it will import different parts of the Zeppelin contract. Like by default, you only have this basic one, and then it will allow you to import some different smart contract snippets, let's say, which will implement some additional functions. So I'll show you after that in our smart contract what we do, but it's pretty much the same. So this is basically how we start to have like a template. Now we need to implement like the functions that are specific to ours. All right, so any questions so far? It's probably a lot of information if you're new to crypto. I'm sure, we won't cover everything, but my aim is to give you like a high level picture. But if there are any questions, just feel free to ask me at any time. All right, so if there are no questions, let me go on, just checking. All right, so let's jump into the code. So this is the project, and it's basically an NPM package. So what you need to do in the beginning is install a couple of libraries, not too many. You saw we want to use Hardhat as the main library that will support compilation, testing, and deployment of the smart contract. We're going to use Eaters.js, which is like a JavaScript library to interface with the blockchain. Waffle is a testing framework for smart contracts. Chai is just like a testing library for Node.js. And these are like a couple of plugins, but we'll go later a little bit in detail. And we also defined some functions here, some scripts that just to easily run like unit tests or compile the smart contract and so on. When you install Hardhat, you need to do some configuration before we can really launch a contract. That's found in the Hardhat config.js. So what we need to specify here is the version of Solidity we are going to use. This is like one of the latest ones, and you have some important configurations to do here before you can start. First one are the networks. So we're writing the smart contract in Solidity. This means we can deploy it to all Ethereum compatible networks. And this includes level 2 networks like Polygon, and it's testing at Mumbai. And you also have like, in order to run tests, you can have your own basically local blockchain just for testing. So what we do here is we need to provide some keys and API URLs, which you'll need later. What you basically need is an account, is a wallet address, which you're going to use for the deployment, because every smart contract is deployed from a wallet, and this wallet needs to pay for the transaction fee. And this wallet is also will be the owner of the smart contract. And so this is basically the private key, and it's stored into the .env file. So never store your private key in any plain text into the repository. Make sure you don't check it in on GitHub, because everybody that has your private key basically can transfer all of your tokens into other accounts. So, and actually, in order to keep myself from errors, I don't use my main wallet for this stuff. I created a new one, which I only use to deploy Underfitted. So in case somebody gets my private key, it's not too much money, not too much private stuff in there. So private key, then the URL. The URL is basically the node which you use to enter the blockchain network. So because you can imagine that the blockchain runs on a protocol called JSON RPC, and you cannot communicate with it like with your browser. It's not HTTP. So what you need there is like a node that can interface from let's say the internet into the blockchain. And if you're running MetaMask is is such a node. In this case, we're not going to use MetaMask. We are going to use one node service. In this case, it's called Alchemy, but there are like other ones, like Ipfs, for example, which basically create this interface between your machine and the blockchain. So you be able to to interact with smart contracts on the chain, and what we really need it for is just for the deployment, but you'll see in a minute. And this one I'll skip for now. We'll come back to it later. All right, so let's take a look on our smart contract. And maybe one more thing before we jump into the code. Now, you've seen here on our contract, we can already check some things like I can check the balance of certain wallet. I can check who the owner of a particular NFT is. But this is just the token ID. Now the question is, where do we store the images and the metadata that you see? And the answer is, so that the important concept here is the so-called token URI. So every ERC 721 contract needs to have this function, where you basically say, okay, I'm interested into seeing the metadata of token ID 4, and it will tell you an address where you can find it. Now, this could be either like a regular web address to an Amazon S3 bucket or whatever. In this case, we uploaded the data on IPFS. So IPFS stands for Interplanetary File System, and it's like a decentralized distributed file system where you can store files. So it's a really cool concept because unlike traditional networks, let's say AWS S3, if Amazon decides to shut your project down, you cannot do much about it, right? So this is centralized service, and you're pretty much at the mercy of their mercy. IPFS is as a data storage, and there are different nodes that hold your data. Now, with IPFS, you're not guaranteed that this data will stay forever. There's a process called garbage collection that will continuously remove data that's not used. But what you can do is so-called pinning. So you can say, I create a node, or I pay a node to pin my data. And there are like services that offer you pinning for free for for 1 gigabyte. So what we do is exactly this. We use a service called metadata. We upload the data there. It uploads it to the IPFS, and now it pins it. So we're not going to lose this data. But the cool thing about decentralization is if you want to make sure that you never lose your NFTs, you can actually spin up an IPFS node yourself and pin your NFTs. And this way you're guaranteed that they won't get lost. Right. So it's a bit more difficult to view this. So there are like different services which offer you the possibility to explore IPFS data. This is one I like. So just basically type ipfs.io IPFS, and then you put the address here. And when I hit enter, you basically see a JSON file, which contains the so-called metadata of the NFT. So it has like a name. In this case, that's the founding membership number 4. So this is this is my token. Let's open it on OpenSea so we can compare. And let's go for, I open one, random one, and then I go to number 4. So this is mine. And then you can see here, it has the name, the description that goes here, the name, the description. You see the properties like accessories, expression, hair, all those cool things are written here into the attributes. And because this is a standard format, for example, OpenSea knows how to interpret this and how to show it into the user interface. And one of the important one is the image, which basically is a URL to your image. So open it, you should be able to see my tote. And what OpenSea basically does is it fetches this data for you and displays it here. And this is what you sometimes see people saying, that the metadata is not stored on chain. And this is true, right? The data is not on the blockchain because it will be ridiculously expensive to do that. So here's the tote, but so it's stored off the chain. But since we're using a decentralized service as well, we don't lose too much from the idea of decentralization, right? Okay, and how we generate this? We have the code here, basically, but it's more or less like Santiago's daughter drew this really beautiful images of people, and basically they consist of different layers like hair, mouth, and so on. Let me open one of the ones that are created with layers. I actually see here, for example, this has the long hair, and you can also explore all the NFTs having the same hair. So see, it's the same, but there we create random combinations of it. And another thing that's basically generated at random is the gradient. We pick 3 colors at random, and the orientation of the gradient is also random. I won't go too much into the details of the code because I want to focus on the smart contract here, but this is the basic idea. And so in the end, we get like we generated 1,000 JSON files basically with the metadata and link to the corresponding images, and we upload it to IPFS. And you now see how we create this link from the IPFS data to the smart contract code. All right, so let's go back to the code. And by the way, any questions at this point? Let's see if everybody is awake or asleep. All right, so let's jump into the code. So we're writing the code in a language called Solidity, which is like some mixture between JavaScript, C++, and Java. And it pretty much looks like, if you're familiar with JavaScript, probably looks mostly like JavaScript. And I won't go now into every detail of Solidity. I just want to give you an overview. What are the important parts of a smart contract? So the first thing is we import the contracts from Zeppelin. So I basically took this from the wizard. But then when you install the Zeppelin dependency, you will have here the contracts, and you can even go in there and explore them. So this is all the code that is implemented by OpenZeppelin. And then you basically say, I create a new smart contract and I inherit from this one. So the concept of inheritance works pretty much like in other languages you're familiar with. So basically our contract will have all the functions defined here. And so these are the basic functions for creating a token. Pausable allows the owner to pause the minting and unpause it. We didn't have to do it for now, but the idea is if you want to stop people from minting, you can do it. And ownable adds some functions that allows you to guard some functions to be executed only by the owner of the smart contract. And you see a couple of examples. Then when you start, you have something you can think about as member variables. And in this case, we only have one actually, which is our token ID counter. So we use, like, again, a class provided by OpenZeppelin, and the counter is just basically a counter. So it starts at 0, and you have a function to say increase it. And this is used to track the state of our, to track how many tokens we already minted. After that, we have a couple of constants, so that we can define them like constant variables. We define them as functions because we want to override them. You see this later. And these are like main parameters of the contract. So the first one is max supply. So we want to have 1,000 tokens, 1,000 memberships. The reserved supply defines how many tokens at the beginning will be reserved for the treasury account. And this is what, so we reserve the first 100, which we give away when we invite some people, or if somebody pays with a credit card, we actually distribute one of these first 100 ones. Then we have something about the pricing. The main price is 5. Now this is a unit that you need to use in Solidity. It's Ether because the main network is Ethereum. But this actually means the currency of the network, the main currency of the network you're deploying to. So since we're deploying Polygon, this will be 5 Matic. And then what we have now is like the first paid NFT starts at 5 and it increases by 0.69 Matic every 10 tokens. And this is defined here. Like the price step, how often we increase is 10, meaning 10 tokens. And this is like another unit, Gwei, which is like, this is basically 0.69 matic. All right, so as you see, it's actually pretty simple from the constants, and yeah, and you see now the code is not so complicated at all as well. I'll skip the constructor for now, and we'll come back to it later. Now we have some other basic functions. We need some read functions, like the base URL. And this is really important because this creates the connection between smart contract and the metadata. Now see, the base URL is exactly the URL we looked at earlier. So it will basically tell you, okay, IPFS, this is the place we uploaded, / and then the smart contract automatically adds the token ID after that. So we need to make sure that this data is uploaded exactly at this place. Then we have some reader functions like read the state of the counter for the total supply. The base price is calculated from, the current price of the token is calculated from the base price. And this is like a simple stepping function to make sure it increases. Then we have like a convenience function we use on the website to automatically get the max supply, the current supply, and the price. And maybe we can even check it out on the live contract. So if you go here, you find exactly these functions. For example, get supply and price. The first one is the max supply is 100, the current supply is 131, and this is the current gas price. By the way, here you can click it and it will convert it into different metrics. So you see this is 7.07 matic. All right, then what do we have next? So we have the two functions pause and unpause. They're exposed externally. This means they can be called from the outside, not only in the smart contract, and they are marked as only owner. So this modifier comes from the owner, from the ownable class, and they basically mean that only the owner will be able to execute this function. And then this is like one of the most important functions is the mint function, which basically creates a new token and puts it on the blockchain. So we start with a couple of requirements. So these are things that need to hold, otherwise the function will fail. All right, and we have some basic checks that the amount of tokens minted is less than max supply, and otherwise we throw an error sorted out. Message value is like a variable for how much basically tokens, how much matic were sent with the request, and it needs to be equal to the current price or higher. Otherwise, we will not allow to mint. So this is basically how we basically implement the paying functionality. And then one other thing we have is that we don't allow one wallet to mint more than one token. So basically say we only allow this for the owner, because the owner address will have this initial supply of 100. So we say you either need to be the owner or your balance needs to be 0. Why we did this? We wanted to avoid speculators. We wanted to avoid some person coming and like minting 100 tokens and wanting to sell them to people later for more money. Of course, you could now create 10 wallets and still do it, but it adds quite a lot of friction. So it's like a safeguard for speculators. And then what you do is you increment your counter, and then you call the save mint function where you provide the message sender. So this is basically the address of the wallet that initiated the transaction. It will be assigned as owner of the NFT and the current token ID. So, and the save mint function is implemented in the ERC721 contract, which comes from OpenZeppelin. Right. So we're making use here of the Open Zeppelin contracts, and what we do here is only do some checks and set the pricing as we want to have it. And then we have the other important function is the withdrawal. Now, you see, people will be minting the token and they'll be paying for it. So the money will land in the smart contract. And when you go here, you see it goes here into the balance. So we currently have 177 Matic on our wallet, but this is now locked into the smart contract. Now, if you want to do something with this money, we actually need to take it out of the smart contract so we can do something in it. So again, this is a function that only the owner may call. And then we will transfer the funds not to the wallet that initiated the transaction, but we directly actually to the wallet that initiated the transaction because it's the owner. Yeah. So only the owner can call this, and then we send the money basically to this address. All right. And then this is something, this is automatic code that comes from the pausable contract. And then let's go back to the constructor. So this is like in C++ or Java, you have the constructor, or you basically call the constructors of your base classes. And what we do here. So we have one argument here called the treasury. And the idea is so in order to deploy the smart contract, we need like a regular wallet because we need its private key to pay for the gas fee to deploy the contract. And we cannot get the private key of another smart contract. And we actually want our owner to be a smart contract. In this case, this is the so-called Gnosis Safe, which is a wallet. It's actually a smart contract that requires multiple signatures in order to perform any kind of action. So in this case, it's me and Santiago need both to sign off every transaction. And we want this contract to own all the NFTs and this contract to contain all the money, so we can build a more robust system so that I can't just take all the money and run away, and neither can Santiago, and we always need to both sign it. And I think in the future we also add some more people to be signers of the contract to be more robust. And so what we basically do is we'll create a wallet that uses only to deploy the contract, and we immediately transfer it to the treasury account. So when we deploy it, we'll put the treasury account here. And so now it belongs to the treasury, and straight away we mint the first 100 tokens. So we go through the reserve supply and we increment the counter and call the safe mint function. So, and they will go, in this case, they go to the owner address because we want the treasury to have them in the beginning, right? And that's actually all the code we have for our smart contract, which I think it's quite simple. And it's like an example of a very, very basic NFT contract. There are like other projects that do some more complicated ones where you have like whitelists and different mint stages, different prices. So this is a fairly straight one. So any questions? Otherwise, I'll go to the testing and deploying section. All right, no questions? Then let's go. Now, how do you actually develop? How does the development process look like? Now, you can continuously deploy this contract on the test network, which costs no money, and test it like interacting with it over Polyscan. But this is not a very, I don't think it's a good way because this is very slow. And the second thing is you really want this contract to be tested, so you make sure you don't have any bugs. And when you change something, so you don't introduce any regressions. That's why we are going to write tests for it. And we put all the tests, so the contract is here on the contracts. I'll come to the mock contract in a minute. But here's our main contract. And on the test, you find the tests for it. And the tests here use the Chai framework, and they're implemented in this common file because we want to reuse them for the two different contracts. But in the end, we have like a function that just goes run tests, and we can provide some high-level parameters like the contract name, the max supply, reserve supply, base price, price factor, and price step. These are our 5 constants. And what you do here, you see these are all our tests. And so what happens is basically before each test is executed, we will use the ethers library to basically create the contract and deploy it on like a local blockchain network. So this is actually very fast, and this is the code to basically create the contract, and you see we will deploy it in the end. And and then this is just a function to write down. And then what we basically do is run a series of tests where we specify what we want to have, and then we do something and expect some conditions. For example, we check that the total supply function works okay. So we can now call the functions we wrote in the smart contract into contract.total supply, and we check that it's equal to the reserved supply, because when a new contract is created, the reserved supply is minted, and we want to make sure it equals the reserved supply. Now I won't go through all the tests in detail, but if you're interested how this is implemented, you can take a look, and maybe just take a look at some of the more complex tests. For example, here should rise an error when price is wrong. So here we make sure that our price is set correctly. So what we do here is mint a token from some address, and we'll send the value which we send there will be the price of the contract minus 1. Well, this is a kind of a way to handle the prices using classes, because they're too big to fit into standard JavaScript numbers. So you kind of need to use these functions. So basically send the current price minus 1, and then we expect the transaction to be reverted with this error message, right? Incorrect price. And then if I mint with the price higher than the current price, I expect this transaction to not be reverted. And if I test with exactly the same price, exactly the price as current price, I also expect it to be reverted. Then we have some more functions here to make sure that the pricing function is implemented correctly. This one, for example, is to make sure that only the treasury can withdraw all the proceeds. So we have here 3 different contracts, 2 different wallets, and like some random wallet cannot do this, the owner cannot do this, only the treasury is allowed to do it. So these are basically our functions. And at this stage, let me show you the mock contract. So one of the problems with just testing our smart contract like this is that we have functions that basically need to mint all the tokens. For example, here, when we check that, we can only mint max supply. So what we do here is go and mint all the tokens. So this takes some time. On my machine, it takes something like 15 seconds, and And like other functions also meet quite a lot, so the tests are slow. And we wanted to have a way to very quickly run tests, and also here when you playing around with the contract, we want to have a small contract. For example, if I want to test what happens when I mint out all the tokens, I don't want to mint 1,000 tokens. I want to deploy a very small contract that only has 10. And this is why we created our mock contract, and you see how it's used in the tests. So the mock contract inherits from our original one and just overrides the constants, nothing else. So it will set the max supply to 10, the reserve supply to 4, and the base price to some like 0.0005 matic. So this is just to enable easier testing. I found this very important to do, to have something like this as a very small contract, so we can very quickly iterate. And now let's run the tests. So we have the scripts npm run test, and so this will now run over the test, and you see this is now the test suite for the mock contract, so it gets executed quite quickly. So maybe for reminder, when we do npm run test, it actually goes here and runs this command. We can also do directly do like hard hat test or whatever, and to run all the tests. It's just an easier way to do this, and the tutorial from Oliver actually walks you through how to create this. Now let's run the full test suite, which will now really do all the tests on the real smart contract, which we're later going to deploy. And see, it takes a bit more time. So you can imagine, like when you're developing something, like you usually write a test that fails, and then you modify it, you start implementing until it works. And you see it takes some time, so yeah. But now, okay, now it went through. Another thing you can do is we use a coverage plugin, which will basically tell you how good your code is covered by tests. So okay, now so it will run the full test suite, and it generates statistic basically telling you how much lines of code you covered, how many branches. And during development, we made sure that this is always reaches 100% everywhere, because we really don't want to have any bugs. Okay, I had even timed out at some point, but it's okay. So we have 100% test coverage everywhere. All right, so what we did now is we have our smart contract, we have our tests implemented and passing. Now we want to deploy it. And what you usually do is not deploy to the main network straight away, because this also costs money. Like on Polygon, it's really cheap. We pay like 20 cents to deploy. But if you're doing Ethereum, it could easily go into hundreds or thousands of dollars. So what you usually want to do first is deploy to a test network. And there are a couple of them on Ethereum, and really only one on Polygon, or one main one. It's the so-called Mumbai test network. So what we're going to do, we make sure we have it configured I have it configured in my MetaMask. So now this wallet, just for testing, is on the Mumbai testnet, and I have some testmatic. I'll send you this one. This is basically at the so-called faucet, which gives you free tokens, right? You can put your address and to send you one matic on the Mumbai testnet. So this is a way basically to pre-fill your wallet with matic, so we can use it for testing. And you see, this is another problem. Another reason why we wanted to have the mock contract is because if I now need to test the real contract, I have to pay 5 matic for an NFT. And this only gives me 1, and I need to do it many times. So that's why I want to have a very small contract that really has very low prices. so I can easily test it. Right. So we have this wallet pre-filled with some Matic, and now we can actually deploy the smart contract. So let me see now the command. So what we do now, so we're using the tests, you're using this local hard hat network. But now we're going to deploy Mumbai. So I have my Alchemy URL created here and my real wallet with some testmatic. And by the way, I didn't show you the Alchemy, but this is more or less how it looks like. You create an application, and this is the test one. You say on which network you want to deploy it. And here it will give you the API, the URL with the API key that you can plug in here. So this is also very well described into the tutorials. And then basically we have our command to deploy on the Mumbai test network. So we'll do npm. Wait, I want to show you the deploy script. So the deploy script you need to write yourself, which is here. It's also like available in the tutorials, and it's actually quite simple. As you see here, half of it is logging, and this is like what executes the deployment. Is basically create one contract from the factory, and you call the deploy function, and these are like the parameters of the constructor. In this case, we get a treasury account, which we'll take from environmental variable. And that's it. That will basically deploy it, again, using the Ethers JavaScript library. And let me see. Now we want to deploy our mock contract on the Dubai test network. So I prepared the command here, but what you actually do is we set the environmental variable to the treasury account. So I use, for the Mumbai, I use 1, and for the Rio deployment, so this is the command for our final production deployment, and this is the address of the treasury, and this is our Gnosis safe, where basically all the money goes, and all the reserved supply of the NFT is stored here. But for this one, we're going to use another, like a regular wallet, and the command is npx hardhat run, and we give it the deploy script, and we need to tell it on which network to deploy. And when we do it, it basically looks like this. From Mumbai. So this is the account we used to deploy from, and this is the current balance we have of, and this is now all the Mumbai test network. So this is all like fiction money. The treasury account we set, and it's done. So this is our new, freshly deployed contract. So we can now head over to Polyscan to see it. Now remember, this is the Mumbai testnet. So I also need to switch to the Mumbai version of the Polyscan, and now I can just search for this smart contract, and here it is. So you see it was created 36 seconds ago from this account, which we have here. And how does it know it's this account? It's basically the public key that corresponds to the private key I provided here in the environmental file. And yeah, so there it is, and let's take a look in the code. Okay, so here, so when you usually deploy a contract for the first time, when you go here to the code, you won't actually see the code, and the reason is that the code is not verified. So there is one more step that you usually need to do. Now we don't need to do this time because I already deployed exactly the same contract. So Polyscan knows the code for it. Otherwise, there is one more command you need to run. It's actually written in the documentation, and it's basically we use the verify plugin and say, okay, verify me this contract, which will upload all the code to Polyscan, so we can see it. And if you go to the read contract, you see that this is actually the mock one. Like the max supply is 10, the price step is 2, the reserve supply is 4. And you see that the current supply should be, where do we have the current supply? Here. The current supply is also 4 because the first 4 were already minted. And you see the owner, and actually now I can check, okay, who's the owner of token ID 1? All right, it's the treasury account. Remember, this is the one we specified here. So they're really minted to the treasury. And now I can also check the token ID, the URL, it's the correct one. So I basically see that it worked. I can even now, let's mint one token. So I'll try it with another. I have a testing account, it's like F2D. So now mint one token with it. So let's go to, I'll connect my wallet. Okay, you see it's connected to F2D. Go to the mint function, and I need to provide the correct price. So it's what we have here, 0.05 matic. I think it's the right one. And when I go right, it opens the MetaMask, and I need to confirm the transaction. Now let's see, it's pending to be confirmed soon, and then I have it, and then I can actually go to OpenSea to check it out. So if you want to go, what happened? So something didn't work. Maybe I didn't set the price right. Let me try again. I always forget how many zeros you have to have. But if you want to see something on OpenSea from the testnet, you go to testnets.opensea.io. Then you can connect your wallet, and you should be able to see the newly minted NFT when it's there. See the transaction. This went through. So now I can go and take a look and read and say, okay, who is the owner of ID 5? And something didn't work. Let's see. Okay, I need to refresh it. Or is it 4? Oh no, this is the balance of it. I need to provide the wallet address. So I can say, oh, how many tokens does this one have? Okay, it's 1. And if I go to owner of 5, it's this one. And if I can copy the contract address and go to OpenSea, and then it's like assets, Mumbai, and then if I put the smart contract address and the token ID, it will open the page for this particular NFT. So this is the smart contract we just created. ID 5 is owned by you. So it's by me because I have this wallet connected there. And you see it's newly minted, so OpenSea still doesn't have the metadata, so I can like speed this up by refreshing the metadata. And here it is. All right, so this is more or less what I wanted to show you, like a high-level overview and the process. I'll share all the links after that to the tutorials and to the repository. And you can take a look. Now, guys, I have like about 15 minutes. So if you have any questions, just feel free to ask. So go ahead.